right, so I have begun before the video and just summarized these goals right here, and it's mostly graphing exponentials. Here's what we gave you the other day, and we said that's the start value. And then if this base here was a number like 3, you knew this was going to be growth. And if it was like 1/3 for the base, then that was going to be decay. You guys remember that so far? Does that all seem right to you? Okay. So I want to take a minute and on page 2, off on the side, would you please just go over there, and I need to make sure you understand these weird 9 to the 0, 9 to the -1, and 9 to the -2. You should be able to do those kind of powers like the back of your hand. Okay, so please figure out 9 to the 0, 9 to the -1, and 9 to the -2. Pause for a second while you write down those 3 answers. Well, 9 to the 0 is just 1. It is not 0, and that's critical. You got to know that. Okay, next one is 9 to the -1. That's 1/9. It is not negative. Powers can't change your answer to negative. They can be a negative power, but notice the answer does not have a negative on it. And last but not least, I square it first, and then I flip it. 1 over 9 squared is 81. 1 over 81. Raise your hand if you had those 3 right. That's most of you. Okay, now graphing reminders. If I just asked you to graph y equals 2x plus 5, I know it's been a while since you've done it, but wouldn't you almost immediately find me some points on the graph? Go find me 3 points on this graph. Just want you to remember this is a critical skill. It's right off the top 20. Basic graphing. And we'll transport these skills into exponentials in a minute. Hudson, walk me through a point. How do you find a point? Okay, you can put it in 2 if you want to. And then what would happen? So y would equal... So it would be close. 2 times 2 is 4. Plus 5 is 9. Okay, too much pressure. Yeah, all right. You were really close. Okay, so now I got 2 comma 9. What else do I do? Well, I make another point. Brady, tell me another one you picked.
1.
And you put in 1. What'd you get?
7.
7 is correct. All right. So you just take in a number, any number you want. Could I put in 17 here? Sure. It just wouldn't graph very nice, so I probably wouldn't pick 17. Would it be smart to use a negative number? Especially today, it would be. Because when you make a negative power, like that's going to be a power later, it really helps. All right, so let's do that one. The most basic graph, 2 to the x. Would you agree it is exponential? Okay, then make me an XY chart, find me 3 points, and use a negative x. I'm going to pause while you find me 3 points. Putting in x is anything you want, except make one of them negative and pick easy numbers. Ethan T., tell me a point you picked.
0.
When you put in 0 for x, what did you get?
1.
Yep, 0 comma 1 is a good point. Turf, tell me a point you picked. All right, and when you put in -2 here for the x, then I would square it first and then give me the answer. 1/4 is good. I bet a lot of people pick -1 because it's just a little easier. So I'm going to do that one. If I did put a -1 here, that flips the 2 and it's 1/2. How many of you had -1? 1/2. All right, good. That's probably the easiest negative to pick. And then how about +1? Well, then you're just putting 2 to the 1, which is 2. And then from there, I bet you can graph it. Go ahead, graph those points. At least 3 of them. And then we're going to talk about where the asymptote is. Because a lot of you, if I hadn't said the word asymptote, probably wouldn't have put an asymptote on your graph. Okay, 0, 1's like right there. -2 comma 1/4 might be like there. -1 comma 1/2 might be like right there. Over 1 up 2 might be like right there. And now I'm going to put a dotted line through all of those. It doesn't have to be dotted. It's just that I didn't want to cover up my nice distinct points. There we go. And I get it wrong because I didn't put the what? Asymptote. Where should the asymptote be? Down here. A lot of people think it's the other way. No, you can put in, if I put an asymptote in like this way, then I'm saying I can't pick any numbers bigger than like 5. I can pick in any number I want. I can put in any x I want. If I want to put an x as 17, I can. So there is no asymptote that goes up and down. There's only an asymptote that goes left and right. That's called a horizontal asymptote. And try to drill this through your head. It's the x-axis, so it's y equals 0 is the HA. Horizontal, what? Asymptote. If you don't have that on your graph, you can't get the credit. I can't give it to you without the asymptote, and it's really common to forget that. Okay, when would it ever move? Do you get, if I had taken this whole graph and put a +5 out here, everything would have moved up 5, including the asymptote. So the asymptote will be at 0 unless there's something out there that moves it up or down. So since there isn't anything out there, the asymptote stays where it is. And you can tell by looking at your graph. You look at this blue graph, you can tell it's going to turn right at 0. And here's the last logical reason. If it went below the green dotted line, it would have turned negative. And a +2 is never going to turn negative by putting it to a power. You might think you could put that to a certain power that it would make it go negative. Nope. What if you use a negative power? Still doesn't turn it negative. It just flips it over. All right? So that's why there's an asymptote line right there, because your y values can never be negative. It starts out with a base at 2. How could it ever go negative? You're putting in powers. Putting in any kind of power won't turn it negative. Okay. Last thought is domain and range. It's been a while, but you absolutely can do these. They're like this. I'm totally giving you the wrong answer, but you know, these kind of things. Make me a domain and range for this. See if you still remember it. The reason I'm making you try to remember it is because there is research that shows when your brain is forced to try to recall it, it'll stick better once I do tell you how to do it. If I just told you how to do it, it wouldn't stick. Brady, domain. Yep, you can write it INF or you can make it like the sideways 8. Bodie, range.
0 to infinity.
Tell me about the brackets and the parentheses.
Parentheses on 0, bracket on infinity.
Close. Infinities always have parentheses too, because you can't touch those spots. Parentheses. All right. That's domain range. That's the horizontal asymptote down there. Y equals 0. And then the last thing is they're going to ask you for the limits. Ooh, been a while since you've been tested on that. Act like it's the ACT test. And they say, what is the right end limit for this function? It always starts with lim of f of x. And then you have to put something under the limit, and then you have to say what it's equal to. The right end limit. Maren, do you know what goes under the lim?
No, I'm blanking.
X approaches, and on the right end, look what x is approaching as I go to the right, as I go way to the right. What is it approaching? Infinity. And then that's equal to, and that the other place is where you put the y. So if I looked at this graph in the big picture, would you agree it's going up and up and up and up? And if I go for way to the right, it's going to be way up. So what do you think the answer is? Judging by your responses, you guys would have failed limits right now. That is how you write the right end limit. The left end limit will be different because it is not approaching infinity in both ways. Like this one doesn't go down forever, does it? It's got a limit. Write the left end limit now and see if you're better on this one. I'm going to pause for a second and I want you to compare your answer with the kid next to you. And if you're stuck, ask for help. Okay, limit of the function as x approaches. And then that will be on every single limit you ever write. Every one you ever write will look just like that. Now, what is x approaching? On this end of the graph, what is x approaching? X is this number. X is this number. Is x really approaching 0? No, it's approaching negative infinity. What is approaching 0 is the y value. That's where that goes. So x approaches negative infinity because that's this kind of direction. That's x. And the y is like the height of the blue line. The y is like the height. And that will be 0 when you go infinitely to the left. Yes?
Do you, when writing like the number as opposed to the infinity symbol, do you write like a plus or a minus to indicate where it is?
I think you're thinking of inside limits.
Okay.
There's a kind of limit where you're going towards the vertical asymptote. This isn't that kind. So all you need is negative on the infinity right there. Okay. I just think we are not awesome at limits yet, so I'm going to give you one more. That is a function. It passes a vertical line test, so I know it's a function. My question is not what the domain and range are. Those would be too easy. It'd be negative infinity and positive infinity in both directions. But what is the left end limit? On the left, write the limit. I'm going to pause for a sec. If I can do one more and almost everybody gets it, then I'll feel like, okay, you remember limits. Tell me how to do the limit on the left side.
Limit of x equals positive infinity, and then
Wait. Now you're not wrong. I'm just asking, should go down here next. As x
approaches positive.
approaches on the left end, over here,
Or negative infinity.
x is approaching negative infinity. The y value is what you said. Y value is approaching infinity. You can write INF or you can write the little sideways 8. I need to know, how many of you had that one right? Okay, you're up to vast majority. So if you need more help on those, ask me. All right, so what happens when we ask you to graph really weird things? Well, you make an XY chart and it's not that bad. Let me show you. If I said e to the x, that's kind of weird, but you'd still make an XY chart. And then you'd think, what the heck is e again? Who's got a short-term memory? It's a decimal. I told you yesterday. I told you it was kind of like, you have to memorize it like you memorized pi, it was 3.14, right? Did you remember e yet? What'd you say?
2.718.
2.7, very good. And we're going to round it off to about 2.7. But for the sake of this, do you get 2.7 squared is a real pain in the butt? And you won't have a calculator. So I'm going to say, would you agree 2.7 is pretty close to 3? So we're going to use e is about 3. It is 2.718, blah, 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 goes on forever. But it's about 3. So when you do this problem, instead of saying that the y is exactly whatever, whenever you're like saying, well, I'm rounding to about 3, put a squiggly equals, and that means your answer is about whatever. So let's like put in 1. Everybody put in 1. If you put in 1, then it's e to the 1, which is e, which is about 3. If you wanted to say 2.7 right there, it'd be fine. It's closer than 3 is, right? What if I put in 2? Do you really want to do 2.7 squared? I don't. I'd rather do about 3 squared and say it's about 9. See what I'm saying? Is your math teacher allowing you to round? Yes. It doesn't seem that crazy to me. We're rounding this thing. I'm saying it's about 3. All right, everybody take a second and figure out what would happen if you put in -1. You're supposed to know what that power does. We practiced it earlier. Just because it's an E, you can substitute for a 3. I'll take it. Thank you. Okay, if you put in a -1 right here, then I'm doing E, which is about 3, to the -1. And that's supposed to be automatic. It's 1/3. Raise your hand if you had 1/3. Okay, good. Bodie, you with me? All right, good. Okay. Another weird, oh yes, question.
Is it not gonna be about 3 or is it just 1?
Oh, good point. It's about 1/3. Yep. And when you graph it, do you get that it's really hard to tell the difference between like 1/3 and 1/2.7? On the graph, it's going to be impossible for me to mark that wrong for you being close. So 3 is pretty much 2.7. I'm saying that's good enough. All right. So what if it's more complicated though? What if there's a number in front? Remember the start value thing? Ooh, it got way more complicated. Oh, scary. Oh, just make an XY chart. It's not that bad. And don't think that this is 6 to the x minus 1. It is not. Why can't you multiply 2 times 3? Because there's a power. Powers come first. That is not 6 to the power of x minus 1. No, math has rules. The rules are the exponents go first. So pick some numbers to put in for x. We'll find a few points together. I'll pause while you try this one. Dominic, would you demonstrate how to put in 0?
Put in 0 in the x box and put in -1.
You get -1 as the power. Good. And then what?
Then your 3 becomes 1/3.
3 becomes 1/3 because this -1 makes it 1/3. Now it's 1/3. And then what?
You times it by 2.
So it's 2 times 1/3. Come on, you can do it.
2/3.
Yeah, it's 2/3. 2/3. That makes sense? All right, now let's try another one. We put in 0. I said everybody put in 1. Random kid. Row 5. 1, 2, 3, 4, 5. Person 4. 1, 2, 3, 4. Xavier, that's you. If I'm putting in a 1 right here, what happens to my power then?
Goes to 0,
Yep, and then what?
and then 3 becomes a 1,
3 to the 0 becomes 1. Good, and then?
and then multiply by 2.
So final answer?
2.
There you go. 1, 2. All right. Jaden Drews, did you use a negative number?
No.
Okay. You don't have to. It brings up an important point. And it's not a rule. But you do have to have 3 points. So Jaden, you must use something else.
2.
I agree. Good call. 2 goes here. 2 minus 1 is 1. 3 to the 1 is 3. 3 times 2, did you have 6? Yep. Now graph it, please, and answer these 3 questions. Where's the asymptote? What's the right end limit? Right limb. And what's the range? All of these are on your next test. I'll pause for a second. When I say it's on the test, it means these are questions we could ask you on the test. All right, the horizontal asymptote based on this thing, I'm trying to figure out if this is exponential growth or decay, because that's another question I could have asked you. And if I go back to what the original problem was, there was an x minus 1 right here. Is this growth or decay? You can look here and say that is a growth because the base is a number bigger than 1. That's growth. So I know it generally is going to look like that. Now, does it actually exactly look like that? Well, it's at 0, 2/3. If I call that 2/3. Over 1 up 2, I feel like it should be steeper than I had it. And then over 2 up 6, whoa, really steep. So yeah, I wasn't going steep enough. And now, That's my graph, and here's my asymptote at 0 again, and that's the x-axis, so it's y equals 0 is the horizontal asymptote. Next up is the right limit. That's this part here, and that's lim of the function as x approaches infinity, because look, the x is here. It's going to the right on the right side, and that's towards infinity. That's supposed to be INF. I'm just going to write INF. And that equals, well, it's going up, 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 infinity. And then the range from 0 to infinity. The lowest it'll ever go is 0, and it won't touch 0, so parentheses. There we go. Okay, now act like it's the test, and this is the hardest kind of R3 I could possibly ask you. Y equals 4 times 3 to the negative x. Now I want you to just ponder it for a second and think to yourself, what is that negative in the exponent going to do to my base? Think this through. My first question for you is, once I deal with that negative, will this be growth or decay? Okay, how many of you figured out that that really means when there's a negative in the power, that this will be like 4 1/3 to the x? Did anybody figure that out? A couple people. Okay, process that. You get that negative powers make things flip, right? It makes the 3 flip to that. So this is decay. And what's the decay factor? That's called the decay factor then. Okay. So, now that you know that, I really pretty much asked you to graph that. Would you make an XY chart? Find me 3 points. There'll be one that's super easy. And I would use a negative number because it'll flip the 1/3 back and then make it easier to work with. Pick 3 numbers. I'm just saying negatives actually work really nice now on this one. Well, 0 is the best. Anything to the 0 power is 1. 1 times 4 is 4. Then I said a negative would be smart. Well, and I probably should put in -1. Brady, why did I say to put in a -1?
Because it makes it positive.
Makes that not positive. It makes it a whole number. So 1/3 changes to 3. And then 3 times 4 makes 12. -1 comma 12. Everett, tell me one more number to put in.
If you put in -2, then like flips it.
It flips it to 3, and then what about the 2?
Does it still do it?
Squares it.
Squares it so that it's 9.
Yes, and 9 times 4 is 36. That got really big, but it's not wrong. What if I just put in a 1? Couldn't I have just put in a 1? Yup. If you just put a 1 there, 1/3 of the 1 is 1/3, and 4 times 1/3 is 4/3. That would have probably been easier. Don't have to have 4 points, but there's 4 points. 0, 4. -1, 12. -2, 36. And 1 comma 4/3. Look at that. They all kind of line up. It looks like it's not going to go below 0. Good thing, because our asymptote's always at y equals 0. unless it gets moved up, which it didn't. If there was like a +7 here, it would have been moved up, but it wasn't. So asymptote, that green dotted line needs to be there. And there you go. That's about as hard as they could possibly get. So today we are doing the odds on the worksheet. I want to start you right now. That'll give you a fair amount of time to work. I will do the first couple with you. The odds. 1, 3, 5, 7, etc. Kaylin, would you read me number 1, please?
If f of x equals 2 to the x.
Anytime you want to change f of x to y, you're totally okay to do that. Because I'm making an xy chart, so I might as well, use a y. You don't have to, but you can. Kaylin, give me some numbers to put in.
You could use -1, 0, and 1.
I like it, and you even set them in order. Smart. Xavier, when you put in -1, what do you get?
1,000.
Yep. Brody, when you put in 0, sorry, Bodie, when you put in 0. And then when you put in 1. Yep. Graph them, everybody. Look for the asymptote. It starts in a certain spot, and you just have to decide if it moved. Ava, the asymptote's along that x-axis. What's its name? True, but there's an equation for it. Y equals 0. The x-axis is y equals 0. That's the HA, horizontal asymptote. My 3 dots come out roughly there. I'm going to just draw a line through them. There we go. Let's do 1, 2, skip a few. Rissy, can you find the first odd one that has E in it? Might not be for a while. Wait, which problem number?
11.
Problem 11. F of x.
1 over e to the power of x.
All right. Do you agree that I said you could round E? It was normally 2.718, so I said pretty much what? 3. So then this is pretty much 1/3 to the x. Is it growth or decay? That's decay. The first thing they ask, if I'm right on this, Rissy, is tell if it's got growth or decay. Doesn't it say that in the directions above it? I think so. So this is decay, because it's like 1/3. And what is the decay factor? It's 1 over e. That's the decay factor. That's the thing that's telling you that it's decay. And remember, e is kind of like 3. What else do I have to do with it, Rissy, besides say that it's decay?
Use limit notation to describe its own behavior.
All right. If I had to graph this, I know exponential decay kind of looks like that. Oh, I made it cross the line. I better try that again. There we go. And I know the asymptote would be there. So I could kind of tell what the limit is, even without fully graphing it. I could kind of know it looks going to look like that, so I could tell the limit pretty easy. Do they want the right end limit or the left end limit? Does it say both? Or does it say just the end behavior? So that's both. So you got to say the left end is this, and then the right end is that. Here's the left limit. Lim of the function as x approaches, well, the left end is this side. So I'm in here. And x are along here. X is going out to the left, so it's going towards negative inf. And the y value, which is the other one after the equal sign, is way up, inf. That's the left end limit, for example. Now, if I needed actual points, I'd just make an XY chart, and I'd assume E is like 3, and then I'd stick in 0, and anything to 0 is 1. And then I'd stick in like -1 to make it flip, which would be nice. And then I'd probably use positive 1. Not too hard. All right, there's a reminder of how to do this stuff. That's all I got for you for today.